Welcome back, Precalcsters. I've learned this morning, I'm not really here yet, but I think that 6, 7 is dead. It's on the way out right now. 6, 7 ain't cool. You know what's cool? 41 or something like that. I don't know how he'd say it. Have you guys heard that yet? It's coming. It's coming. The freshmen knew what I was talking about. All right. Yep, they're cool. Unlike, don't have to say it. All right. So we are continuing on. I think you guys are cool, just for the record. We're going to continue with our functions, and there's one more little bullet point here. We are going to be talking about what it means when we discuss an even function and an odd function. Now, I'm not going to write it, but right off the bat, this is different than even numbers and odd numbers. I don't care at all about the number that I see. Do you guys know the difference between even and odd numbers? What's an even number? 2, 4, 6, 8. Who do we appreciate? Holloway. Okay. You gave me an example. Basil. Oh, we also appreciate the Cowboys, of course. Basil, you had something else. If it's even, what's it divisible by? 2. That's just how we define it, right? And if it's not, it's odd. So when we're looking at these, those are numbers. Even and odd functions is just a continuation of our symmetry idea. So as we're looking at these, we're going to just sneak them in as definitions. Even functions. And I don't really want to have to define it formally, but I'll write it. Even function. Okay, I'm going to do odd functions like right next to it, so I'm going to just do it kind of concisely here. An even function. We have a really mathy definition. I'm going to ask you guys for what it would look like on a graph or what this actually means. A function is said to be even if for all x. And did we start doing this yesterday? Mm-hmm. Okay. Everybody cool with for all? Mm-hmm. For all x, what's this one? We could say in the set of, but I'm going to be more specific with the set. In the what do you think this says? What's the set I'm saying the x must come from? Good. For all x in the domain of a function, it's even if, we'll say even if, when we plug in f of negative x, it spits out the exact same thing as f of x. That's it. If for all x values, if you plug in negative x, it spits out the same function that you started with. You have an even function. Now, graphically, what does this look like? And I'm going to sketch it in bright pink. You do not have to write it down, but I just want to think about it. I'm going to sketch some function, and I'm only going to do half of it right now, because we're going to see if we can make sense of it. If I pick x and it spits out this value, if it's even, if I pick negative x, what's it do? So here's negative x. Is it going to spit out the same y value or a different one? Same. There's not a whole lot of confidence in that statement, but this literally says they're the exact same. And it happens for every x. So if I pick this one, it'd be, I'm making this up. I don't have the function in front of me. But that point does this, right? Same y value. This function, to me, looks like it's kind of symmetric. Symmetric where? About the y-axis. So easy piece of cake. Even functions, here's a formal definition. This is the part that we're going to rely on more than not, but I want to get this practice. All that this really and truly means is that we have symmetry about where? Symmetry about y-axis. All right. Now, we would care about this. One, it saves a ton of work in calculus next year. I can think of a ton of different problems where if you recognize a function's even or odd, it literally cuts your work in half. Worth knowing these things. Graphing it, same thing. If I know a function is even, I only have to pick 0, 1, 2, 3 to get the basic idea, and then I just reflect it over the y-axis. Saves us time. It's an efficiency deal. Okay, a function can be even if this is true. For an odd function, I'm not going to write the for all x in the domain, bless you, but we see a very similar statement. For an odd function, what happens is we check f of negative x. And when we plug this in, it turns out to be the same thing as negative f of x. Okay, this is a harder one to think about. Same thing, pink graph just for us to make sense of it, and we'll just write the statement and then we'll check a couple functions and see if we can't get practice with it. So if I plot the point f of negative x, maybe it's here, and it spits out this number. According to this, it's the same thing as if I did f of x, but something changes. F of negative x is right here. When I plug in f of x, they're the same number, but something's different. It's sine, which means this point would be down here, right? So if I did this for infinitely many points, maybe I get a graph that looks like this. And there is a graph, I guarantee, that looks like this, but I don't care about the actual function itself. Is this thing symmetric? I'm going to say yes. It's not the way you want it to be. Is it x-axis symmetry? No. Not a chance. What is it? Origin. We have origin symmetry, and it can be harder to see, but origin symmetry is what we get out of an odd function. Now, the easiest place that this applies, like right off the bat, I don't know how much you saw last year. How much trig did you guys do in Algebra 2 last year? Like, did you graph waves and understand how to graph waves and such? Okay, so here's the deal. It's super easy. Some of you understood it. There is a really easy way to do them. If you didn't do well with it last year, that makes sense. It's an Algebra 2 idea the first time you see it. Do you remember what sine and cosine look like? Yes. So I'll tell you right off the bat, we don't have to draw them. We'll see the trig stuff eventually. But cosine is even. You only have to graph the positive side of it, and then you just reflect it over the y-axis, and you get the whole entire wave. Cosine and, gosh, 1 over cosine. Did you see 6 trig functions or 3? You know sine, cosine, tangent. Do you know secant, cosecant, and cotangent? Okay, so if cosine is even, 1 over cosine is defined as the secant. Secant is also even. Sine is an odd function. Cosine is even. And then we run from there. If that doesn't mean anything to you right now, that's okay. We'll see it. I just wanted to make sure that those things are at least in your head. Cool. Here we go. We are going to verify on Desmos, but I just want us to do real quickly. Example, determine if f, and I'll say f of x, is, now I wrote 2 options for us, but there's a third one that we need to consider. It could be even, right? A function can be even. Or what? Odd, good. There's another option here that we didn't even write down. Is it true that all numbers can be classified as even or odd? Ooh, sometimes there's one number that can't. 0. So is 0 even? No. Or odd? So what would you say it is? It's 0. Would you agree that neither is another way we could say that? Good. Follow up. Do you guys say neither or neither? Neither. I think I say either or, neither nor is what I think I say. I don't know why it changes. Either this or that. Like, that's a correct usage of neither and either. Either, either, I don't know. All right, here's a function. Love it. You guys are going to love this one. I called it f. F of x is 2x cubed plus 3x. Get warm. Uh-oh. I'm stuck. Now, I'm just going to look back real quick because, I just can't remember it. If I'm checking an even function, the very first thing that we wrote was f of what? We wrote f of negative x, right? Okay. What's the very first thing we wrote when we were checking if a function's odd? So what do you think we're going to immediately begin with anytime we're trying to determine if a function is even or odd? Let's find f of negative x. Like right off the bat. It's either going to be this, the same thing that I started with, or the opposite of it, everything will change, or it's neither. Let's deal with it. So We are going to make sure that your exponent game is good here. I'm going to see it here. I'm going to evaluate f of negative x. This literally means in my function, anywhere that there was an x, it gets replaced with a what? Okay, so there's going to be some weird stuff. I'm going to try to use colors to match this. I'm not going to be able to. I'm just going to keep it here. Can you tell me what I've done wrong? Yeah, this is not the right thing, right? X got replaced with negative x. Let's make sure it's really clear that that's all that happened. And 3 times negative x. The parentheses, if you don't include them, you're going to be wrong. Like every once in a while, maybe by coincidence you're good, but you're going to be wrong. Okay, here's the first thing that we just need to check. This looks weird when we do it with the x. What's negative x times negative x times negative x? It's negative x cubed, right? So this is not, if you just look at your work and we don't talk about it, it probably won't even look like anything really happened. Do you agree that when we think about what happens with a cube, this is what it becomes? And I'm going to get rid of those parentheses here in a minute, but negative x cubed is just negative x cubed, which is a weird statement because where the parentheses are is what changes. Okay, this one changes to what? Do you want me to write plus the same, or can I just call this negative 3x right now? Okay, what happens here? Can I rewrite this in a more meaningful and clear way? Negative 2x cubed minus 3x. Everybody okay with that? Now, quick check. Some of you might be able to do this. Can you tell me right now with confidence, even or odd? I have one person saying odd. Anybody else clearly see that's the case right now? Okay, you're going to. If you don't see it yet, you will. I need it to turn into this or the exact opposite, right? If I want to make something here look like it, both the signs are wrong, yeah? If I factor out a negative, and this part, I would never do this on a like everyday problem that I'm doing, but if we factor out a negative, what stays inside? Everybody's still cool. Which notice, what did we call this at the very beginning of our problem? So we just found that when I do f of negative x, it gave me literally negative f of x. This part I wouldn't normally do. This is what I'm looking for. This is a pretty handy technique. So we just found the following relationship. And this is just a summary. We showed that if I do f of negative x for this function, it is the exact same thing as negative f of x. Everybody agree with that? We then can conclude with confidence, therefore, f is, which one changes the sign in front? Odd. Okay, I do not want you to make the association incorrectly. The common mistake that I've seen people do year after year is they look and they say, okay, here's my function, it's x cubed. 3 is an odd number, this is an odd function. No. This is a 3, and it is an odd number, but that does not immediately dictate that we're going to have an odd function. You have to do this check. Cool. Feel all right with that one? Want to try another one on your own? Cool. All right. I want you guys, last one, and then we're going to talk a little, maybe. We'll come back to that. F of x in this problem is x to the 4th minus x squared minus 1. I'm going to pause this. I want you guys to determine even, odd, or neither. Show enough work that you can convince me. When we do this, what do you notice about the last line that I wrote and the very first line when we started the problem? Like, even when we just wrote it. They're the exact same, right? It's not the same, but every sign is backwards, so it's definitely not odd. Is it even? Yeah, if f of negative x spits out exactly what we needed, this is even, therefore f even, or feven if you'd rather. Cool. All right. Feel okay. All right. For this next part, I'm going to talk at you guys for a minute. Basil, did you finish the quiz yet? Yeah, did you hand it? You didn't hand it in yesterday, right?
Oh yeah.
Yeah, I'll take it here in a second. Okay, conceptually, I want you guys to follow along. You don't have to jot all this down. Difference quotients looked terrible. Do you remember that? Okay, they looked awful. I'm going to claim we've been doing difference quotients yesterday. You did run the bell ringer today. You didn't even notice it. Check this out. That little idea of a difference quotient becomes fundamental in calculus. And in past years, I've taught it in here, in Precalc, but we were fine without it at that point in time. I'm going to consider some function. Here it is. And I'm going to let some x value exist, and then I'm going to go over some horizontal distance, and I don't know how far it is. I'm just going to say, we'll just make it up. Let's say I go h over. So I've gone h in that direction. What's this new coordinate right here? It's not just x, it's not just h. It's x plus h. Everybody agree with that? Okay, if this function is called f, and I'm going to get rid of this part here, just a little bit so I can label it and it's not ugly. Okay, here we go. Do you guys get near as stressed as I do when that sort of thing happens? You don't? Okay, apparently not, if you don't know what I'm talking about. What's the y value right here? I mean, it could be y, but it coordinates with that point, I think. F of, what did I plug in to get that? It's just x. I plugged in x and it spit this out. What's this y coordinate right here? That's f of x plus h, right? Okay, so you may recognize some of this stuff from your difference quotient, yeah? Here's my check. If I asked you guys to find me the average rate of change right here, it's the slope of that line, right? Let's just figure out what this would look like. What's the change in y? What's the higher y value? Okay, so that's like y2, right? Minus what? Okay, all divided by what goes in the denominator? You're right, but we're going to get there. It's x plus h minus x. When we do difference quotients, we are literally just finding the average rate of change. Now, this is one tiny step away from calculus. If you understand that there's a slope to that line, you're going to be finding calculus. The algebra can be harder. Do you want to see it become calculus real quick? Okay, it's going to take 30 seconds. I just randomly picked h, right? I didn't pick how close it was. Could I pick a smaller h and do it here instead? Okay, so I'm only going to do 2 or 3 of these. Could I find the slope of this line? And it'd be the same formula, right? But h has changed. Okay, can I get closer than that? Like I went that far that time. Can I get closer? How close could I get? Could I get closer than 1 away? Could I get closer than 0.1? Closer than 0.01? I could get as close as I wanted to, arbitrarily close, right? So check it out. I'm going to pick this h distance, and I could still find the slope between this red point and this point. That's essentially the same. When I draw this last average rate of change, my secant line, does it look like a secant line anymore? How many times does it look like it's touching my function? Once. Which means as I let h get really, really small, instead of a secant line, what did it just change into? It changed into a tangent line. The same method for finding the slope exists. This is the entire motivation behind Calc 1. This is Calc 1 in a nutshell. Now there's a lot of really awesome stuff you can do with it, but we've been doing all of calculus except that last little part. You guys are killing it. Cool. All right, that's all I have for today. You get some homework. It might be all I have for today. This is not a threat. If we finish the homework early, again, not a threat. It's going to sound like it. We'll start the next section, but that'll make it so that we have time for homework tomorrow in class, and it's just going to perpetuate on and 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 on. Cool. All right. We didn't have any homework from here, did we? Because we agreed that I won't give you homework. What? Last night? Okay, weird. So let's figure it out. We get today homework 1.4. I haven't updated your classroom in a week? All right. I upload the videos every day. I thought I'd do this. Maybe I don't save it. Weird. My bad. All right, homework 1.4. You will find this waiting for you on page. This is 1. Is it 1.4? Yeah, I'm just losing days at a time here. Weird. Homework 1.5, page 56. And let's see here. It's going to look like a lot, but it's because they're sporadically arranged. 1 through 7.
Is that all vocab?
I think so. 1 through 7. 16. 20. 24. 32. Ooh, didn't I tell you I was going to give you only odds? 31. 36. 7. Gosh.
32.
I changed 32 to 31. 61. 71. 73. 89. I can. Homework 1.5, page 56. Numbers 1 through 7. 16. 20. 24. 31. 37. 61. 71. 73. 89. Do you guys remember the commercial? You're probably too young. Like, I was obviously saying the number's weird. There's a commercial where stuff was on sale for $9.99, and that was the whole premise of the commercial, and it's lived in my head completely free for like a decade or more. $9.99. All right, this is due tomorrow.